Hi, my name is Matt Parker. Welcome to the Hexagonal TDD and Ruby screencast series. This is the first episode. The goal of this series is really to just demystify what people are calling hexagonal architecture, and also to fill a gap that exists around the implications that it has for TDD. I'm kind of assuming that you've already heard some things about hexagonal architecture, that you've read a few blog posts or something, or have had some exposure to these ideas. Maybe you've even tried it, um, and perhaps even struggled with TDD within a hexagonal architecture. So let's talk a little bit about how we're going to do the screencast series. We're going to build bits and pieces of an application that already exists at Pivotal. It's an open source application called Whiteboard. Pivotal is the company I work for, by the way. It's an extreme programming consulting company, and we also build a platform as a service called Cloud Foundry. We also build a big data suite of applications. The Whiteboard application was originally built to support our consulting services. We have all these offices all over the world, and all these pivots in those offices that are working with companies. We bring companies into the office, we do extreme programming with them, we pair with them, we TDD with them, we have these fast feedback loops with them, we have these balanced teams. It's a really powerful way to build software together with clients. And we have this moment each day where we get together and share out things, where every single person in the office gets together and gets a chance to ask every single other person something, right? A question maybe. It's a moment to tap into the hive mind. And we built an application to help facilitate this. It's called Whiteboard. It's really simple. First, you create a whiteboard for your office in the application. And then, throughout the day, pivots will start posting stuff to the whiteboard for their office. Things like events, interestings, helps, new faces, all that kind of stuff. Each day, a pivot will present the stand-up to the office by essentially just pulling stuff off the whiteboard that seems relevant to talk about that day, which may not be everything on the whiteboard, right? There may be stuff that's event far in the future that they don't want to talk about that day. Afterwards, the presenter will email out all those stand-up items to everyone in the company, not just the people in the office. And they'll post it to the blog, and then they'll go and archive the stand-up, which is I guess the real-world equivalent of that would be like walking up to a physical whiteboard and erasing stuff on it. So let's hop into RubyMine. Let's just jump into some code. I have a repository here ready for us. It has two folders in it right now, a folder called plugins, which we'll actually won't get back to until later episodes, and a folder called whiteboard. And whiteboard is actually a gem. Whiteboard is where all of our high-level policy is going to be contained, and where we're going to start with our TDD. So right now it doesn't have anything much very interesting in it. It has a gem file, which says just go look in the gem spec. It has a gem spec, which just says, hey, we depend on our spec in development. And that's really it, okay? I had this create whiteboard spec, but it's empty right now. And that's where we're going to start. Let's just start with our very first use case, creating a whiteboard. So let's describe how we're going to do that. Okay, so describe create whiteboard. Well, what is it? What do you need to do when you create a whiteboard? Well, for starters, we require you to give a whiteboard a name, right? You have to give it a name. It could be named after your office, like the San Francisco office or the New York office. We also require that the names be unique. And also, when you create the whiteboard, you have to actually save that information, right? So save the whiteboard. That's fairly obvious. Okay, so there's some interesting stuff that we could go ahead and point out now. There's implications and boundaries that are always present when you're developing software. These first two are really all about validation, right? And that it has implications about the user interface. Because if somebody is using the application and interacting with it through some real-world mechanism like a website, or maybe like a RESTful API, or maybe even a command line interface, they're going to want to know if they did something wrong. Like if they gave you a name but it was empty, or if the name had already been taken, you're going to need to tell them that somehow. However, here in the high-level policy, we don't want to couple it directly to a specific implementation of user interface. The user interface and its rate of change and the reasons it will change will vary from the actual high-level policy. Those two things are different. But we can go ahead and point out that this does have UI implications, and in fact, requiring a name to be unique also implies that there's persistence going on, right? Because you have to have a memory of other things that have been created before you can know if your thing is unique or not. Saving the whiteboard also obviously has persistence implications. So let's just do the first one. It requires a name. Well, we have to imagine what kind of API we're going to have for our use case. And this is where it gets kind of fun. The most obvious use case API that we could use right now is just a function. How about calling it create whiteboard and you give it a name? And for now, we're going to give it an empty name because we're trying to prove that our thing forces you to give it a real name. Okay, so you create a whiteboard. The name is empty. Then what? What should we expect? Well, we should expect that the UI was told that a name was required, but none was given. But we don't have a UI that really exists here, right? This is high-level policy. It's not concerned with that low-level detail yet. So we're going to create a spy that we can spy on. So what if you plugged a GUI in here, and then you expect, like if you could spy on the validation errors that were sent back to it, it would include something like the name was required. Okay, that's kind of cool, but where does this GUI come from? Well, let's just go ahead and create it, GUI spy. If you've only ever used something like RSpec mocks, then you may not really understand what a spy is, or at least not be very familiar with it. So we're going to hand roll our test doubles in this screencast series. Let me jump back to here real quick, and let's just take a little detour into the land of doubles. So there's all kinds of different test doubles that we use. There's dummies, there's stubs, there's spies, there's mocks, there's fakes. And the interesting thing is there's sort of a hierarchy among some of these. Like a stub is a type of dummy, and a spy is a type of stub, and a mock is a type of spy. Fakes are something else, and we'll talk about that in a little bit. For now, right now, we're going to use a spy. A spy you tend to use at a boundary, at an architectural boundary, like the one we're using right now. We're injecting a GUI into our use case. But you're using it in the situation where the thing you're injecting, you couldn't necessarily assert on the behavior that that thing should exhibit, right? You don't know. All you know is really the interface it needs to conform to, and you really just kind of want to interrogate how how the messages were sent to it. So that's where we're at right now with our GUI spy. I'll go ahead and just make a little GUI spy here. So let's run this. Okay, so it says it doesn't know what create whiteboard is, of course. For now, I'm just going to, even though this is going to be production code, I'm going to throw it in the test file for now, and we'll separate these things out into separate files afterwards. So we're going to create a whiteboard. It requires a name. It requires a GUI. And we're going to send a message back like validation failed. And we're going to give it the reason or reasons. That's what we could do for now. And of course, it's going to say our GUI spy doesn't actually respond to validation failed, which makes sense, right? Because it doesn't. It doesn't yet conform to the interface that we would expect of anything in production pretending to be a GUI. So let's go ahead and create that method. Validation failed. Errors. And we could say spy validation errors. Errors. Yeah. And we could create a little reader here for spy validation errors. So now we can actually get to it in our test. And now it passes. So this is a spy. This is how spies work. Here's the actual production interface. And here's the thing we're spying on after the fact. What were the errors actually sent back to the GUI? Okay. That's all we had to do to get this one going. Let's go ahead and remove that. Next, let's do it requires names be unique. So let's go create a whiteboard. Actually, I'll just copy paste all of this down here. So let me give it an actual valid name. And let's do that a couple of times, right? Because here we'll get into the situation where now we should assume that we should get the name unique failure. Okay, but there's really something missing here. We don't have any way to persist stuff yet, and we certainly don't want our high-level policy use case to be coupled to a specific low-level implementation detail about how something gets persisted, like to a database, is it SQL, are we using some kind of document store, are we just throwing stuff on a file system, like what is it? We don't really care at this point. So we're going to plug a repo into it, a data repository for our whiteboards, and we're actually going to build a fake. So we're going to call this the fake whiteboard repo. So again, this is one of those type of test doubles, fake. But it's a bit different from all the other ones in that a fake actually exhibits real behavior. It conforms to the behavioral expectations that you would have around anything claiming to be whatever the type is that the fake is pretending to be. Um, the trick is underneath the hood, it just cheats. It somehow is cheating in its implementation. For us, we're going to create a whiteboard repository that instead of actually persisting stuff to disk, beyond the lifetime of a process, we're just going to throw everything in memory, which is the actual cheat. Okay. By the way, if you want to learn more about these doubles, start by Googling the Little Mocker. Uncle Bob wrote a fantastic blog post that's really actually short and concise that clearly explains all these different test double types. Okay, so let's run this. Well, we know we're going to have to do this here now, and this thing needs to go ahead and take this. Now let's run it. Okay, so it doesn't know what a fake whiteboard repo is yet. Well, that's cool. Let's make one. Just throw it down here. Name required. Okay, great. So now it's just saying we're not sending the right message back, which makes sense. So if name is empty, well, that's when we do this. Name was required. Else if repo find by name. So if the repo already had something with that name, then we could say you didn't honor the uniqueness constraint. And otherwise, everything was good, so let's go ahead and save a whiteboard. This whiteboard entity doesn't yet exist in our production code either, so I'm doing a little programming by wishful thinking here at the moment. Let's go ahead and run that and see where it takes us. Okay, so it says, hey, your fake whiteboard repo doesn't respond to find by name, which is true. But remember how I said a fake whiteboard repo should conform to all the same behavior that we would expect out of a real whiteboard repository, one that isn't cheating. Well, that means it needs to pass the tests for the type whiteboard repo, which means we need to write tests. So let's start to describe what a whiteboard repo should do. Well, it should find by name. It finds by name. Let's create a couple of whiteboards. We'll make one for New York and one for San Francisco. Let's spin up a repo. For now, I'll just hard code this repo into here. We'll save New York and San Francisco. And then what? What should we do? We should make some assertions like expect repo find by name, New York's name, to equal New York. And the same would be true for SF, right? SF. Okay, great. So let's run that. Okay, so it says, hey, I don't know what this whiteboard is. So let's go up here. We'll put this up at the top because, again, this is a real entity that should exist in our production code. It's not test code. The whiteboard is a real production class. We know it needs to take a name. Oops, sorry. There we go. And we know we are looking stuff up by name, so we need all of that. Okay, so now it says, hey, your repo doesn't know how to save. It doesn't respond to save. So save whiteboard. And what else? It probably doesn't respond to find by name either. So find by name. Okay, great. Now it's just nilling out, which means that we can just go ahead and implement this. So here's how we're going to cheat. We're going to initialize, there we go, whiteboards, then empty array. And then down here, let's go ahead and save it. And then here, find by name, well, we can just find a whiteboard with that name. Okay, great. Now that should actually work. Do all the tests pass? They do. All 3 tests pass. Great. Okay, so now we got this whiteboard. So let's go back up here. Let's look at what else we have to do. Well, it needs to save the whiteboard. Okay, well, how do we know that it saved the whiteboard? We kind of know that it did something here by saving the whiteboard. There clearly was a memory between these two things. But the other thing that any client of this use case is going to want is some kind of handle back to the whiteboard that got created, right? Some kind of give me back an identifier. So it sends an ID for the created whiteboard back to the GUI. Back to the GUI. I can't really. There we go. Okay, great. Let's see. I'll just copy pasta this, and I'll drop that. Okay. So I think now we're going to want to spy on maybe like the created whiteboard ID. And all we're really going to assert here is that it should just exist. The whiteboard ID should have been sent back. So it's going to say, great, I don't know what a created whiteboard ID is for your GUI spy. So let's go deal with that. So GUI spy, adder reader, spy, created whiteboard ID. Okay, so now what does it say? Yeah, it's just nilling out. So up here, we should take this a little bit farther, right? So this whiteboard, we save, and then we tell the GUI whiteboard created. And we could give it back the whiteboard ID. That's pretty cool. Let's run that. Of course, our GUI spy isn't going to respond to whiteboard created, and our whiteboard doesn't respond to an ID. So actually, let me go ahead and make that an accessor. You'll see why in a second. Undefined method whiteboard created for GUI spy, as I said. So def whiteboard created, give me the ID, and then we'll spy on the created ID. Okay. Expect nil to evaluate to true. Okay, great. So now we need to actually send back a real ID. Well, how's it going to get an ID? Well, it's actually the responsibility of the repository to assign IDs to whiteboards when they get saved. Which means that there's more behavior that we need to put in here. It creates unique IDs for whiteboards when saved. Okay, let's see. I'm going to copy pasta that setup to get us going. So we have a New York and an SF whiteboard again, and I think we could expect a few things like the New York ID to be, as well as the SF ID, and they should not equal. Okay, let's run that. Okay, great. So then up here, well, again, I think we can get away with doing something simple, like using the secure random UUID. So we could say whiteboard.id equals secure random UUID. Okay, do all the tests pass? They do. Interesting. Okay, let's go ahead and clean this up real quick, by the way. So this setup, I copy pasted between these two tests. We can just go ahead and clean that up. Pull these out to be lets. And I have a little macro that'll do that for me. And this bit here, where we actually do the saving and change the state, we'll do in the before. And now we don't have to repeat that setup anymore between the two. Right, so there's our little contract for our whiteboard repository. Also notice that we're still hard coding our whiteboard repo in here. Let's not do that. In order not to do that, I'm going to pull this out to be a top level describe block. And then I'm going to wrap it in a method called whiteboard repo contract. And you pass in the repo class. And then we can just move this up into here. And then we can use the repo class here. And then back down at the bottom, right beneath our fake whiteboard repo, we can say whiteboard repo contract, fake whiteboard repo. Yeah, and all the tests still pass. Cool. Okay, so now we have a little use case. It's a very simple use case. We have a very simple kind of API for it. It's just a function that you call. We've inverted some key dependencies across boundaries, like the GUI and the repo. And we have a little message passing protocol that we teased out as well. We use spies as well as a fake. And we talked about when you might do one of these things versus the other. Use a spy when you need to inject some sort of double, but you can't really assert on the behavior that the double's type should exhibit. Instead, all you can really do is assert on the messages that are passed. Whereas the repo we used a fake for because a repo, we do know the behavior that you would expect out of a repository. And we can use a fake there, and it's very kind of common and almost classic to create an in-memory version of that you can cheaply use in your tests. And in this way, we're kind of blending both the London School and the Detroit School of TDD. We're using both mocks, but we're also doing state-based testing, right? It's this kind of nice blend that works really well in this case. We're mocking across the boundaries. Okay, so I think the last thing we should do is really just put all these things in the right place, right? To make this much more clear. Okay, so why don't we grab this stuff, create whiteboard here, and we'll create a file. Let's put it up in here. Whiteboard use cases, create whiteboard. Cool. Okay. And then our entity, let's put that in a file too. Let's see, we'll put up lib whiteboard entities and whiteboard. Okay. This contract here, I'll leave this here for now. Later we'll actually extract that out and put it in a place that can be accessed by other gyms that are trying to implement the repo contract for a whiteboard. But for now, I'll just go ahead and leave it in here, which means that I simply need to create, well, let's see. We need to go into our lib directory, and let's just go ahead and make a whiteboard.rb where we go ahead and require the whiteboard use cases, create whiteboard. And inside of that, it depends on the whiteboard entity, so we should make that dependency explicit by saying require whiteboard entities whiteboard. Okay, so then now back here in the test, we can just say require whiteboard. And all the tests should still pass, so let's try to run them. Yeah, all 5 tests will pass. Okay, so hopefully that has started to show you how you can get started with the hexagonal architecture, how you can start teasing out the high level of policy of your application, independent of the low level details like, what is the interface really going to look like? We don't know yet. How are we really going to persist all this stuff? Doesn't matter yet. What is the business logic though? What is the actual use case? And I realize this is a pretty trivial example. The business logic is very obvious here, right? Inside our use case. There's not a whole lot going on there. If it grew much larger, I'd probably extract a method object here and do some composed method refactorings inside of that. But for now, I think this is fine. In the next episode, we're going to create a Rails application that's going to consume this use case. And then in the episode following that, we'll create a persistence plugin that will implement the whiteboard repo contract. And thanks for listening.